There's an interesting debate that we could put on the table, and it's between Jim's model, which I'm somewhat familiar with at this point, and
is Jim here?
Yeah.
Oh, awesome! Right. He must be the blue face that's the only one.
So
left.
we could take a shot at this a dialectic between these two ideas. So.
Continuing the March 13th edition of the Electric View today, we will be debating the nature of the Sun and its connection to the local part of our galaxy. What does this connection look like, and how much do we really know?
Okay, well, I could go 3 slides or so. We could step through.
Yeah, I've got them.
So go back to the first. There we go. Okay. So I'm basing this mainly on things that Don Scott has talked about, like with his, electric cables in the sky and all that. So here, this is my understanding of the situation of the heliosphere, is that there's a current, and you can see how wide it is, and over to the right, pretty much that the bands are 3 colors of the orange and the gray and the orange, and then even beyond that. So it's a very large current, bigger than the whole heliosphere. And of course, the heliosphere goes much further than the orbit of Jupiter. And then way inside that is the sun. So you don't see the current on the left, just like you don't see when there's a comet, the tail is going away from the sun, but the current is coming in toward it is just as powerful. It's just the discharge in that direction doesn't amount to much. It's just electrons. But once it impacts the object, whatever it is, then there's a lot of discharge. And so that's why you see a tail only on one side. So anyway, so that's the picture of the current that's powering the heliosphere. So now let's go to the next slide. So if you zoom in, then the sun is a little tiny dot in the middle of the heliosphere. And there's a much smaller, just a portion of that big current gets funneled in to the sun. And then there's a magnetic field that corresponds. It's called the sun's magnetic field, but actually it's really caused by the currents coming in. And the thing I'm pointing out here is that the current that comes into the sun is perpendicular to the actual current that comes from the center of the galaxy, the big one. They're perpendicular to each other. So now go on to the next slide. The next one. The one I sent later. Yeah, there we go. Yeah. So here the same thing is happening. A current is coming from the sun, a big current, just like the other current was coming from the center of the galaxy. And the current into the Earth is perpendicular to it. Same as with the sun. So this pattern of a magnetic field sort of forcing a current to come in orthogonal to itself and then dissipate out and rejoin to the right. That's a standard pattern that exists at the galactic level, at the solar system level. I don't know if it exists at higher levels, but it exists at least at those two. So what this means, and so if it's not even clear that the orbital path of the solar system. Well, let's go back up. Let's go back up to the first slide. There we go. Okay. Now the question is, what path is the heliosphere following? Well, from what Don Scott said, it might kind of move at a kind of a very slow rate along its current, right? But as far as its rotation around the galactic center, if you think of the spiral arms, and this is somewhere out on a spiral arm, well, the whole arm is rotating. So it isn't clear from this picture what the actual direction of the heliosphere is. But because of the fact that the perpendicularity of those two currents, it isn't going to be a helix, because the whatever the direction is, it's not in the direction of the perpendicular to the plane of the solar system. It's something much more complicated than that.
The one thing that just to interject before Jim goes, the one thing that I found interesting, because it's a little segue again, or interstitial, but I was looking at this antenna, and just as far as relating it to the galaxy and the movement of the galaxy. But if you think of these as currents, and then kind of the scalar aspect of what we see, this was just a antenna. They were not modeling the galaxy or galaxies by any means. They were looking at it as an antenna, but the radiation pattern is this, right? And then we certainly see that. So anyway, I thought we found that interesting, and that is, if you consider the movement of what Richard is proposing, a current, we could argue from a scalar standpoint, we're kind of seeing this behavior pretty clearly. So I'm
and
that
behavior is, well, yeah, but that behavior that you're seeing is due to apparently two currents, and that's the middle of them because of the load that the galaxy has made. But I would still defer to Jim. So
this is definitely episode 4 material.
Well, this picture here, that's actually a really good picture, and that is kind of like showing the equivalent of like a cometary tail to the sun. But you do have to realize that that has nothing to do with our direction, any more than a cometary tail has to do with the direction of a comet. And in this case, what's not shown in this picture is the direction of the motion of the sun is actually almost at a right angle to those red arrows there.
okay,
right.
Yeah,
If we look at the, let me bring up the.
Yeah.
So wouldn't that mean that the current has to be moving that direction as well, sort of like a whip moving?
Well, if you go to a picture of the local interstellar cloud, you see the
this
blue
one good?
in that picture right there. If you see the kind of the blue arrows there, that's the direction of the red arrow in Richard's picture. So you get the idea of they're showing the way the clouds, supposedly clouds, are blowing past the sun, but the sun's direction of motion is actually at a right angle to that. So.
This way. Now, how do they measure that, or how do they determine that?
Yeah, actually, there's a number of methods by pinging off other objects. That's basically a combination of proper motions and redshifts and where they go together, kind of. So.
Mm-hmm.
But yeah, his picture is like he's basically zooming in. This is like a huge scale thing, and his picture is like zooming in, and it's showing how really the motion is just in the local part of the filament we're in.
so if I was to guess, like, imagine from what you've told me before, that this image that we're seeing would be, the tail would be pointing away from the local cloud in the area, the middle part, and sort of putting towards the G cloud. And this is just supposition, of course. That's where the tail's going, but the motion is actually traveling in the direction that arrow's going. Like our tail might be reaching to Alpha Centauri, but that has nothing to do with...
Yeah, actually the tail tail would be in the other direction. A lot.
Okay.
Again, the red arrows in Richards match the blue arrows in this, as far as kind of away from galactic center.
Yeah. I also mentioned when we put this out that there is talk by Donald Scott and others with regards to the idea of cathodic and anodic stars. Basically functioning, because electricity will function completely good in reverse. It doesn't really care which direction we're going, just obviously ions go one way and the electrons go in the other. But obviously seeing some of these caught in clouds, they seem to have tails on them like comets, and they're stars, obviously, or solar systems. Because, they're so, anyway. So, the idea that there could be just like the tightly bound corpuscles or anode tufts on the top of the sun, that they are all sort of vibrating off each other, might be more how our sun operates with regards to its electrical connection and magnetic connection to this power source, which are these clouds, which are obviously highly ionized material. And it's pulling these electrons with a seemingly pumping action, as we noted from Voyager crossing this boundary over and over again as it moved back and forth, the heliopause. And how do we relate that to whether or not, for example, the IBEX picture with our ring of neutralized ions. I don't know what direction that is, but I have seen that it changed over time. In the last 3 or 4 years, it looks like it's a different pattern than it was when they first took the picture. So this is all. I'm just impressed that anyone can make sense of all that data, and I'm hoping that you can.
The one that I started looking at last night as that email came through, I found pretty interesting. Looking at this, it's Mira, right? This star with a tail, right? And what is happening with this thing? And I'm sure that Don has looked at this very deeply. I wanted to look at it for the first time, but I'm certainly seeing, just by playing around with, Photoshop and curves and stuff, and I'm certainly seeing this vortex movement and, what kind of things we see along the that axis of the cylinder there, and different spatial wavelengths throughout that, and they certainly decrease as you come in towards low R's as you come in. So anyway, interesting beginning of looking at this thing.
The vortex type might be what's called on my website a spire. I'm not sure if it is, but it is one of the vortex types that connects to stars. So maybe it's changing into one or the other way around. I don't know.
Well, we also could be looking at this the wrong way. Our bias is to put comets that way, but this could be very easily a vertical picture. And this could be the current feeding into a star. We could be looking at it the wrong way.
What's the word about this Mira thing? I mean,
that's just one of many. That's just one of many. I was just showing an example that it's accepted that this happens. But if you go and read Donald Scott's book, The Electric Sky, or into some of his work on the Electric Cosmos page, he describes anodic and cathodic stars. Basically, inside, for example, the Orion Nebula, you can see that there's these stars with large, tails coming off of them. But that doesn't seem to be what's happening with us. We might be working on an anodic system where we're it's only because of Jupiter and Saturn and those are working off of are feeding from our sun. But as Jim says, we might actually have a different thing where it's also getting current from the overall flow of plasma through the galaxy as well. So I'm open to either because this is something that we really need to understand. And besides nebula, which are glowing, and these tails, which are also glowing, we have very little to go on as to the nature of their connection. Jim's work has been better than most that I've seen because of the just understanding where we are in the galaxy and how the motions of our star affect our current levels and so forth. I really don't know where this goes from here. Reading Richard's, I didn't try to think of the sun as having a cathodic tail or a tail on it at all, but it could possibly have. But like I said, when I saw the IBEX pictures of the ring around of neutralized atoms, I figured we were sort of like a misshapen corpuscle squeezed among other corpuscles, like the one around Proxima Centauri and so forth. And then these fields are sort of making a pumping action and having electrons go down to the top, and of course ions along the solar wind. But it's obviously more complex than that. My simplistic vision is needs revision. So.
Yeah, I think what really helps is if you look at pictures of like the Flame Nebula. That to me is the most telling one. That tells you what's missing, like in a lot of the solar system current.
The one that I have as the picture for the electric view. Oh no, this one here. Okay, let's take a look.
Yes, see, there's some that show more. Right, that's a good one. You can see that there's current flow up and more or less up and down through the thing, but there is a point where looks like an equatorial current sheet, effectively. I mean, there is a place where charge sprays radially outward, and the mistake, if you couldn't see that, you could be out there and wondering what's the main current flow here. You could be out there where there's sitting out in that current sheet, seeing charge clearly blowing by you, and think that's the main current flow here. In our solar system, I'd argue we can match our solar system to this. You could put the plane of the solar system more or less in where that charge is flowing out from the sun at the center. And yet what we're clearly missing is that there is current flow up and down through the ecliptic plane. That would be what looks like the twisted helix here is actually in dark mode. It would have to be in dark mode in our solar system right now.
Yes, because we don't see it.
Perhaps in the past that was the bright polar column going off in that direction. But that gives you an idea of our orbital plane. And what we are aware of right now is all that the charge that's blasting out from the sun crossing that. Now, the mistake would be thinking that that's the main current here. And that's kind of where Richard's pictures fit in with this. The local interstellar cloud is like that braided cloud going up and down through there, whereas if you zoom in to Richard's picture, it's like catching the equivalent of the tail going out, and so on.
What I'm looking at here is an equatorial current coming out the along the middle or bottom of the picture, and obviously the main current snaking from the lower left to the upper right, so to speak, or to the middle, right. Upper middle. And it obviously has a twist to it and looks wonderful. I'm seeing other stars, and I'm picturing now that other stars can be powered by other parts of this current. They don't have to be just along the main one. They could be part of this nebula and be brown dwarfs or white dwarfs or obviously if they go through different currents and switch, they could change color or change luminosity or so forth.
There's another picture I'd like to bring into the discussion.
Sure. Certainly.
So anyway, this is the birth of stars. So here it's energetic enough of a system that the currents themselves are in glow mode. And so you can see those currents going from star to star. In fact, the stars are formed by the currents. It's not that the stars are passing through the currents or anything. It's current itself that creates the star. So in our case, those currents are not in glow mode because, you know, they're older. They probably looked like that when they first got born, but then the energy has subsided. So we're connected to, I don't know what the stars are. That'd be something interesting to figure out exactly which ones, but we're part of a sequence of stars all in the same current. So that's still true. So it still looks like that. It's just not in glow mode. And so if you talk about the sun moving anywhere, it's the current that's moving somewhere, and the sun is part of the current. So it's not that the sun is passing by some source of energy.
Well, you're right.
This is the geometry.
I can't argue with that.
Okay.
But it is possible that instead of just, say, up one part of the, like on the current, we could be sort of, as I believe Jim is, if I'm interpreting this correctly, Jim is saying that we're attached to the outside of one of these clouds, and we're sort of spiraling along with it. But Jim would have to be, I still defer to him.
Well, yeah, on the scale it would be here. So if that's the scale like the local interstellar cloud, then we'd be on the surface of that one, and then there's obviously smaller scale filaments going into the stars from that.
Well, yeah, we're trying to understand what we're looking at, but I mean, remember when this all looked like a haze when we first started back in 1950 or 1960, and then now we're at a point now where we can start defining individual filaments. You know, and of course there's some amazing shots where we see filaments around the stars in great detail now in certain deep pictures from Hubble and so forth. So,
while I have you for 1 second here, I have a lot of curiosities about the dynamic geometry involved inside of the filamenting of galactic structures, and these Birkeland currents clearly are portals. So the geometry of opening holes and how systems open and close really fascinates me. When you guys were talking about the Birkeland currents and things like that, Donald Scott, actually I gave my work to Donald Scott for review, and Donald Scott said that my work is as if you were standing inside of a Birkeland current and you could see all of the intricate details going on around you. Now, my curiosity is, how does information, how is it encoded or embedded inside of these galactic structures? Because clearly what's happening here is a lot of information, and then what we have coming in from our sun right now to the Earth is could be coherent information, and then a newer structure. Either way, no matter what, this information is encoded and rides along these streams, and I believe it has a quantum geometry, geometric structure to the space-time dynamic. So, Richard, I don't know if you could touch, Richard or Jim, I don't know if you could touch on any of that. I mean, I assume where the Markland convection happens is where the information is going to be confined or condensed along the cylindrical sheets where the counter rotation occurs, and also along the central filament. And any information on the central filament would be great.
Well, what do you mean by information? What kind of information?
Everything is information. So what I mean by information is the information, because what's building these stars, these stars are concretions that are being fed and built by these filaments. So indeed, any type of information, whether it be, and it seems like it might be broken down into the plasma state, whatever seems to be happening here, because as before we used to think like information going into a black hole, it gets destroyed by a continuum, and then it's debatable. It can come out or whatever, but this is like going into the Birkeland current, and information flow clearly happens and is
well, you thinking of
distributed.
Birkeland? You think of a Birkeland current as like a radio wave, and somebody's broadcasting over it or something?
Everything is moving through it. I believe that the Birkeland currents are fundamental, and it's one of the most fundamental things in reality, and it goes from the macro to the micro. Birkeland currents flow from the macro to the micro all the way down, and
there's an argument for that.
As far as the frequencies, right? If you go all the way up to infinite frequency and all the way down to zero frequency, right?
Well, it just, the simplest terms, it is a natural way for plasma, which seems to be ubiquitous in the universe at many levels, to try to balance charges between two places where charges are separated. No matter where that is, they like to do this motion. In that sense, I can totally agree with Buddy that now, as to whether or not we could determine information, or humans could determine information traveling along that, and can we hear the screams of a dying civilization coming across the, across the Birkeland current from another star? I'm not so sure, but I do understand that everything that we are, every vibration that we make, eventually somehow is now connected to, even in a minute scale, to the ionosphere and so forth, and therefore out into the cosmos. And I think Michael Clarage said something similar when he was doing his video, where he said, all the information or all the voltage goes in on the sun side, and then, so every day it flows out back along the current and so forth. I just, as a poetic notion.
It gets into this Chronos, it gets into this Chronos issue with our grand friend Saturn, but the time aspect and our perception of time and how we exist in time, and its relationship to scale is really profound, and I think it's an area that hasn't been considered to the extent that it certainly can be, I believe. So one of the things, let me see if I can get this real quick, but one of the guys that Gene introduced me to that ultimately has a pretty fascinating theory that is certainly compelling to me these days is hopefully he's here, but it's Dewey. It's his reciprocal theory. Here we go. Yeah. Dewey Larson. And I'm finding this thing just fascinating because he's got a physics that's based on this 1 over R relationship, space over time, and if you have the opportunity and a little bit of time just to kind of entertain it for a little bit, it's pretty fascinating. He was in 1959. He has the same kind of persona a bit, maybe a little bit harder than Buckminster Fuller, but it's certainly worth looking at because he takes on all these things, and very, very similar to a lot of the paradigms in the electric universe. So.
Well, I can factor in on something that was said a little while ago about communication traveling down, say, a Birkeland current. And I remember Don Scott saying somewhere in a talk that, field-aligned current, that information or communication could travel instantaneously over these great long distances. And, of course, I wondered very much like everybody else in the crowd, what do you mean by that? What do you mean by communication? And it was interesting. And then this is completely just one of these, fantasy kind of things that went through my mind when I was talking with some people is that it seems that our civilization ran into some big problems when we started playing around with nuclear bombs. And, what if whatever results from a nuclear explosion is communicated instantaneously to far, far reaches of the galaxy, and what effect does that have? Anyway, that's one of those out there comments. That's all I wanted to say.
That's not that out there. I think Sheldrake said the same thing in a certain way.
Yeah, you're right. Right along the same lines, and this is where Dewey Larson goes into that area where you go superluminal as far as his physics goes. So it's there's no barrier at the speed of light. It's more like a permittivity for transverse waves.
Well, it's like we've said, if the rules of electricity and such are dominant in the universe, then it is natural, because the formula for static electricity doesn't have time in it. It just is. There's so charges can balance fairly quickly. So that could cause some very interesting effects, because you would sense charge moving from, let's say, this body to this body, and every single thing in the solar system and every single thing in the universe technically should respond instantly to that charge differential.
Right. So there's no such concept as quickly. It's instantaneous, right? No time.
There's no time to it. It would just be sensed in
eternity. Time goes away.
Obviously, though, if the effects of that will affect certain, because there's inertia in the switching, like it takes time to induct and then so forth. So electromagnetism takes time, but gravity and electrostatics are instant forces. But unlike mass, that apparently does not shift very easily, perhaps maybe it can shift in steps, as others have said, the idea that a charge can shift instantly. Let's say if another object entered into the heliosphere, say like Saturn or anything really, if it enters in the heliosphere and then suddenly the sun and it discharge to each other, well, the change of charges from one point to the other would be fairly instant, and everything could suddenly be disbalanced, so the charge of the sun suddenly goes up by 10% or something, and that could affect all the other bodies instantly. Suddenly there's 10% more force on this body and 10% for, and so on, and depending on the R-square rule and so on. And then that would not cascade through the whole universe. It would be instantly felt as far away as Andromeda, although Andromeda wouldn't give a crap. I'm just saying it's too minor to matter. But, Proxima Centauri could feel it instantly and go, wow, that's weird.
Okay, this seems really pretty crucial to me. A pointer.
Especially since they wouldn't see the lightning bolt, they'd feel the force before they saw the flash that caused those things to exchange charges.
Yeah.
Because that's a transverse wave. That would take 4.5 years to get to Proxima Centauri.
Mm-hmm. Yeah, this seems really. And it also harkens to the discussion about the local cloud and the flame nebula. Is that discussion?
Yeah, I think we might want to go back to that, actually.
Yeah.
Local cloud.
Well, and of course, that's Jupiter.
There you go.
There it is.
And some references to the age of things, such as, this is a young star, that's an old star, and so on.
Right.
I had to get rid of that, all of that. Well, I felt I needed to start over because I took astronomy class and I learned a bunch of things about the ages of stars. But I felt that if we define stars differently as a potential current, then all bets are off. If you increase the current, then you're going to get a brighter star or a bluer star. If you decrease it, you're going to get something that's redder, right?
Mm-hmm.
So we have to rethink our concept of how old something is, or making assumptions about that. That's all I wanted to say.
Mm-hmm. Well, and that's absolutely true. I mean, Don Scott's interpretation of surface current versus, basically, surface current to size, basically, is the scale now. So and the surface density current is per square meter, and it can only take so much. And then once you're at white hot, that's it. You can't really go any higher, or you're going to have, a fission event, so to speak, as he calls it, where you have to barf out some new material from inside of yourself, cause a nova, so to speak, to then create basically other planets that will, or another star to handle the current load.
Wow.
Yeah, I mean that's where it starts getting back into the Schauberger and everything, where you have this implosion event, and with the cavitation, the sonoluminescence. What could perhaps be happening is that those frequencies shoot up to infinity, and it's just like on a piano where you have sympathetic vibration, to bring Dale Pons back into the conversation. If you have frequencies that are like super, super high, or the wavelengths like way, way small. And once again, if you're thinking super luminal, they'll ring down, and you'll get the white ultimately, because you're only looking at one octave there. That's only one octave of the electromagnetic spectrum. And it's ultimately way down. It's way below infinity. I'm sure of that. But if you start going up there and it starts resonating really, really high, it'll ring down. Just like you can hold like a low C on the piano and hit like a high C, and that low one will ring. Just to get back to our tuning forks.
Well, this is on a. Well, that is. I mean, I can understand what you mean by what you're saying, but this would just be. This is just a simple amount of the fact that you can't handle anymore. It's a physical limitation of matter. At a certain point, your inner positive charge will touch the outer negative charge, and all electrons on the surface of that star will rush to that point. And once that happens, it will literally explode material out of that point, and it will be ejected in, and it will pile up, plowing into itself, and of course it will turn into a sphere or many spheres, and it's basically barfing out your insides in a stellar way. And that.
So what do you think then about binary stars?
Well, that's what.
Do you visualize it that way?
Yes, that's what. And Don Scott says it right there when he talks about the electrical fissioning. Basically, some event in the past caused these stars to some current ran through the system. When it ran through the system, it overcharged certain bodies because they could not handle it, and they split into. Because that's the way to lower that need, you have to increase your surface area. And the easiest way to increase your surface area is to just split into another ball. And then, mathematically, you have more surface area. And this is the same process which caused the 2013 comet explosion when it came in, or the asteroid explosion over Russia. When it came in, that event occurred where the positive charges touched the other one, and the whole thing just blew to pieces, and it tried to give itself more and more area as it went further and further into the atmosphere or charge of the Earth. And you can't handle it. You can't handle that much charge. It will explode.
Well, that makes a lot of sense, actually. You're talking about the Tunguska?
That's 1908. That was the same type of thing, except for that one was so powerful it actually had apparently some tendrils reaching down, and so at about 7 miles they made a connection between the tendrils reaching up. This is from witness testimony, so it was. But so that's why it was that charged. It was actually had Birkeland currents coming down from it. It looked like a pillar coming towards the Earth.